Okay, so this is about the report for experiment 6, understanding indicators. So in the first one, you're going to create a table summarizing the volumes for your titrations, when you got color change, those kinds of, well, here's just the volume. What volumes did it take for you to get to the equivalence points for your different ones? Now in 2, you're going to add then the initial color change uh, before the equivalence. So some of them are going to be single, like binary. So like phenolphthalein, I showed in the pre-lab, colorless and then pink. But some you'll see different colors. So just summarize that. Now in 3, just kind of identifying visually which one was the best. And so you likely already did 4, and now in 4, you'll actually find which one's the best. So you're going to determine the concentration, write the balanced equation for the neutralization reaction using the volumes and so on. So in here, what you know is that if you have an acid-base relationship, if it's like HCl and NaOH is monoprotic 1-to-1, this looks like a dilution calculation, but it's really bad to get in the habit of just writing M1V1 equals M2V2. What you really want to do is you want to relate it back. Which species do you know the moles and the volume and the concentration? That will allow you to solve for the moles. And so in your practice titration, we gave you the concentrations for both, so that way you can find whether or not you were right. So in next week, you're going to be solving for this concentration. So I think it's best just to mirror that today. All right, so how do we do this? So what you do is you're going to uh, then write it. And so we can see the difference between phosphoric acid and sulfuric acid, right? There's different ratios, different amounts from that balanced equation. So for one of them, you're going to know the concentration of volume for it. And so if we know the concentration in the volume, then we know the moles. If we molarity is moles over volume in liters, but it's also millimoles over volume in milliliters. And we'll see. So you can keep it like this, or I'll show you in a minute the other way. And now through the balanced equation, you can relate those moles to the other species. And we can see, since it takes 2-to-1, then we simply divide by 2, and you can do this clearly with dimensional analysis. And now in the acid, then we always pipette in, right? All those moles came from the pipette. So we'll pipette in the same volume for all your runs. The only volume is going to change is the base here. And so now that we know moles in volume, we can find concentration. And you can see why it's convenient now. Millimoles over milliliters, the milli cancels, gives us moles over liter, molarity. So it's the same thing. So here's another view at the same type of problem. So from Kim Libre, same, given you volumes and concentrations and volume. So we know volume and concentration for one of the species. So that allows us to find the moles of that species. And then through the balanced equation, get moles of the other. And now we know moles and volume, we can find the concentration. And so if we look at the step, then we get the moles by taking molarity times volume in liters. You don't have to, you can keep it in millimoles, but if you're not comfortable, here's that example. And now through the balanced equation, we can convert moles of base into moles of acid. And then to get the concentration, we simply take those moles of acid and divide it by the volume of acid it reported. All right. So that's the calculations you need. And then you can calculate percent error. I gotta go back before here. So now you're just gonna show the work for all of them. So 4, you do it for one of the trials. And now in 8 and 5, you're gonna repeat it all, but you're just gonna show those results in a table and analyze your results and draw your conclusions. So how do we kind of compare? Well, percent error is a great way to be able to compare those numbers. And now let me go ahead. So the post-lab question here, list all the possible indicators. This, you just go back to the beginning of the lab in the background. That's an easy one. And now in 8, then I talked about this in the pre-lab. Does this support your experience? So again, the reason for it is most people kind of view it like Beer's law, where you have this nice linear relationship. But we can see that you'll see that from your indicators, knowing where they change color. You have a large volume here with nothing happening, and then you'll have all the color change from all of them over a very short volume. All right. And so you went 5 mils afterwards, and so maybe you saw like that it was relatively flat up there. So again, we're just kind of trying to address that misconception. All right, that's it.